folks. Today we're going to be talking about permutations and combinations. These both deal with special situations to determine the number of ways to do something. So we'll start out with talking about 4 people in a group, Abby, Betty, Chance, and Delton. And we want to figure out how many ways there are to choose a president and a vice president from those 4 people, and decide when listing these out if order matters or not. So what we'll do is we'll write out a set and list all the possibilities to help us figure out the number here. So we want to stay organized, that way we don't miss any. We're going to start by giving Abby president. So when we're listing these out, we'll let our first position be president and our second position be the vice president. So we'll choose Abby with Betty first, then Abby with Chance, and Abby with Delton. And that lists all the way Abby could be president. Then we'll let Betty be president, so she can be with Abby, or with Chance, or with Delton. And then hopefully you're seeing the pattern. There were 3 for each of those 2, so there should be 3 for each with Chance and Delton to finish off. So Chance with Abby, Chance with Betty, Chance with Delton, and then Delton gets to be with Abby, Betty, and Chance. And order mattered because when we said DA here, that was different than AD because that first position said president. This one has Abby president. This one says Delton is president. So yes, order matters. And there are 12 ways possible. Okay, now we're going to look at lining them up to race the mile. So this time we're looking at the top 3. So first place, second place, third place. Again, for this one, order does matter because if you rearrange them, they're talking about a different way they ended the race. So we'll start out with Abby getting first and Betty getting second. Then we'll fill in what's possible for third. So then it could be with Chance or it could be with Delton. Then we'll change up the second place and let Chance be second place. Again, that could be with 2 different people. We could put that Betty in third place, or we could put Delton in third place. Then we'll let Delton get second, with Betty for third place, or with Chance for third place. And there ended up being 6 here. So I'm going to go ahead and start a second row so we can make sure we get all of the ones for each person. We're going to let Betty get first place now. So with Abby and Chance, then Betty, Abby, Delton. Second place will change up again. So then with Abby first, and then we'll let Delton go next. Then we've got Delton being second place to finish up here, and putting that with both the possible options. Okay, I want you to pause the video and take care of those last 2 rows for me. One with Chance getting the first place and one with Delton getting the first place. Okay, so these are what they should look like. There were 24 total ways, and we already decided order mattered. Now we're going to talk about 3 of the 4, so it's similar to the question up above, but this time it's talking about just going out for ice cream. So when we're talking about just going and doing something, it doesn't give us special jobs for these. Order isn't mattering here for these ones. And with that, we're just picking a group of 3 people. So I'm going to choose Abby, Betty, and Chance to be my group of 3, which really means that everybody but Delton goes out for ice cream. The second one, then, I want to leave someone else out. I'll let Abby, Betty, and Delton go together. Then I'll let Abby, Delton, and Chance go together. And finally, we want to let Abby be left out. So we'll let Betty, Chance, and Delton go together. And if I rearrange these, like B, A, C, it still says that Betty, Abby, and Chance are going out for ice cream. So it's identical to that first one we list out. So there are only 4 possible ways for this one. And what we're going to talk about is how these relate to permutations and combinations. So we're going to take some notes below here. A permutation is without replacement or repeats. So we can't use the same person more than once. in those situations that we just talked about, all of them, we couldn't have a vice president and a president who was the same person. We couldn't have the first place, second place, and third place person be the same. And we couldn't take the same person out for the 3 ice creams. That doesn't make sense. So no repeats. But permutation is where order matters. And a combination is where it doesn't. Still without repeats. And they give us the formula for each of these. Okay, and what I'm going to do is talk about these in terms of the situations that we just used. So looking at the A and B from the previous problem and using this formula, I'll use it for this second one because we decided order did matter. It's a little bit more interesting with the 3 positions instead of the just 2. We're going to fill out this formula just to the side here or below wherever you have room in context of what's happening here. So the N is talking about your number of choices. That's our 4 people. And the R is how many you're actually selecting. So that would look like for us 4 factorial. That's what that exclamation point means. And then this would be 4 minus 2 is 2 factorial. So we'll take a minute to explain what a factorial does, just using this example here. It takes the number you see and multiplies it by every integer below it until you hit the number 1. So 4 factorial is a shorthand for 4 times 3 times 2 times 1. 2 factorial would just be 2 times 1. And then you'll notice some things cancel out here. So with this, oh, excuse me, for this one, our R was actually 3 for this one. I was doing this one up above. So this actually would have been a 1 factorial, which is just regular 1. Then when we see this expression, we've got on top 4 times 3 times 2 is 24, and on the bottom we have a 1. Generally, when we see this, we have a pattern of something canceling out. In the case of 1s, it doesn't really make it any more simple for the process. Now, I was actually doing this one accidentally, and I'll show you for this one, that would look a little bit more interesting. 4 times 3 times 2 times 1 over 2 times 1, and both of those actually cross out. Now, this process is actually something we've seen before without calling it a permutation. When we're talking about the number of ways to choose president and vice president, that's a situation we're choosing 1 from this group and 1 for this group. But we have the same 4 people for each choice. The first one, there are 4 options, but the second one, as soon as we choose someone to be president, they can no longer be vice president, so it ends up being 4 times 3 for the 12 we got there. Similar here, we'll see those cross out. There were 3 choices to be made, 4 times 3 times 2. So a lot of times you'll see me, if I know it's a permutation, I will just draw out my blanks and fill it out that way. Okay, let's go talk about a combination. You'll notice in the formula here there's a little bit extra because the combination order doesn't matter. And if order doesn't matter, we don't want to repeat ourselves with different options. So this R factorial is representing the repeats that we're taking out of the situation. So I'll show you with the option C, which was our only combination here. So this time we had our n value being 4, so it's still 4 factorial on the top. But on the bottom, we're going to have an R factorial here and still the n minus R. So our n4 minus R is 3, gives us 1 factorial. But we've also got an additional R factorial, or 3 factorial, and they write it first, so I will too. And we can expand this out. 4 times 3 times 2 times 1, all divided by 3 times 2 times 1, and then 1 factorial is just 1. And then our 3, 2, and 1 goes away on top and bottom, leaving us the 4 over 1. So this formula can be very helpful, especially in terms of permutations, because it gets rid of us having to list out every single possibility to know how many possibilities there will be. So just practice with the formula here. We're going to do some without context problems, just practicing each one. So for this permutation, we'll set it up with our formula. On top, we'll have our 6 factorial, And on the bottom, you just subtract those 2 factorial. I do want to show you something with these factorials that is helpful for these types of problems. When writing 6 factorial, I could choose to write it as 6 times 5 times 4 times 3 times 2 times 1. But I can write it in a couple different ways that may be more helpful. I can also say 6 times 5 factorial, because the 5 factorial takes care of the rest. I could do 6 times 5 times 4 factorial, and I can really stop at any number here that I'd like to. And why that's helpful is what I'll usually do here as I go through these is peel off the top number until the bottom number shows up. That way they can cancel. So let's practice that on this one. The top we're going to start at 6 and stop as soon as we see the number 2. So 6 times 5 times 4 times 3 times 2, and then toss on the factorial, divided by 2 factorial, and those cancel. Then we've got 30 times 12, which is 360 different ways that this could choose 4 out of 6 without replacement where order matters. Okay, so it really is context for some situation that we just weren't given yet. On the next one, we're choosing 3 items out of 10, where we're not replacing the item and order matters. So let's fill out our formula here again. 10 factorial on the top. 10 minus 3 is 7. That'll go on the bottom. So peeling off the top, 10 times 9 times 8 times 7 factorial, and then 7 factorial on the bottom. We've got 72 times 10, so 720 ways for this one. Last one is a combination, so we're using this formula, and I'll show you how to peel with these ones since there are 2 items on the bottom. So I've got a 10 factorial on the top for sure. On the bottom, starting with that number I see, and then doing the subtraction for the second part. So I still have the same situation that I do over here, but there's an additional number on the bottom. So when I'm peeling off, I'm going to peel off till I see the bigger number. So 10 times 9 times 8 times 7 factorial. Switched up the order there, sorry about that. Then on the bottom, 3 factorial over 7 factorial, those will cancel. So I know I have this 720, and then this really says 3 times 2 times 1. So then I'm going and taking this and dividing it by 6. So 120 ways for this one. And now that we know what each of these things mean, we're going to determine them, and I'll use these first couple examples to show you how we can actually use our calculator as well. Those formulas are helpful. They're built into your calculator though, so we'll get to use them. I did want to show you how to work them out for 2 reasons. One, it's really important to me that you understand the meaning here, that this is really filling in the blanks for 4. And this one, it's still filling in the blanks, but it's also dividing off the number that you're repeating, so it's not as obvious there. These formulas in your calculator work almost always, but the second reason I'm showing you how to do it by hand is because there are a couple occasions where your calculator, if you type them in, will give you an error overflow, and in that case you'd have to do it by hand. Okay, so on these ones, just a couple notes again on the top. Permutations and combinations both are repeats are not allowed, so we'll just say no repeats. Counting principle are the fill in the blanks, and repeats are okay here for these. So that's our situation where it was like you could answer true or false, true or false, true or false, and we can usually write that pattern to some power. Or when you were choosing outfits and you had one item from each group, pants were separate, shirts were separate, shoes were separate. Again, you can fill in the blanks with your different numbers there. Okay, difference between permutation and combination. Permutation, you're going to see words that mean order or ranking, and combination is just a group or a collection of items. So first up it said, the ski club with 10 members is to choose 3 officers, captain, co-captain, and secretary, and we want to find how many ways those offices can be filled. So first of all, you're going to decide, can you repeat in this situation or can you not repeat? And because this is talking about choosing different offices, you can't have someone be captain, co-captain, and secretary, so this is a permutation or combination because no repeats. And because they are separate offices with different jobs, it cannot be repeated. This is a permutation. So you can abbreviate, but go ahead and jot down permutation. This is how you'll do it on your homework as well. And then how our formula is going to look is we're going to start with a capital letter, either P or C for your permutation combination. And then we'll put the large total number on the left and the how many we're selecting on the right. So our total members was 10, but we're selecting only 3 of them. So this is 10P3, and I'll show you how to type this in on your calculator. So go ahead and grab it out. You're going to start by typing in the number that comes first, the number 10, and then you're going to hit Math, over to Probability, and both permutation and combination filled in, also factorial there if you'd ever need that. Okay, scrolling down, grab the permutation, then type in 3, and it does the formula for you. This one's 720. And I want to do this one particularly to match the one that we just did to show you that it really is the same as that process that we just completed. Okay, so we're going to go ahead and write 720 and answer the question. It said how many ways to choose the office, so 720 ways. Next up, the company Siesta has 10 members on its board of directors. Says in how many ways can they elect a president, vice president, secretary, or treasurer. So again, this one is no repeats are allowed. Okay, with no repeats, we have to be a permutation or a combination. And this one's very similar to the one before. They're selecting different jobs, so that is a permutation. If you flip around the order of those people, they would have different jobs, thus different meaning. So we're going to go ahead and jot down perm, and then starting out with 10 members, this time we're choosing 4. Okay, just to show you another feature on your calculator, if you had just typed in a permutation, you can do second enter, and that'll bring it back up, and then you can go edit those numbers that you typed in. Okay, so I'm just going to edit mine to the number 4. That saves a couple of steps as you're typing stuff in your calculator. So this time it's 540. Different ways they can fill those positions. Okay, combination is the same way. If you want to find it on your calculator, type your total first, then math over to probability and combination. Okay, I wanted to show you that because I'm going to have you do these next 3 for me. Pause the video, take care of those, and then I'll show you the answers to go ahead and check them. Alright, let's check these ones. The first 2 are very similar. They're talking about just a group of people on a city commission and a group of people on a committee. So these ones are combinations. All of the people chosen had the same job, so it didn't matter if you reorganized them, it still had the same meaning. So this one's a combination. On number 7, it really wasn't clear if repeats were allowed or not allowed. We assume if we're talking about DJing that they're not going to allow songs repeated. Wouldn't be a very good DJ otherwise, but it didn't clarify. So I would take 2 answers on this one. Okay, one dealing with our multiplication counting principle, where we've got those strings without replacement, or with replacement, excuse me. So 8 to the 4th would have worked. Or because of this word arranged, if we're thinking combination or permutation, the only option I want here is a permutation because that word arrange specifically means order. Okay, so those are your options there. I'm going to have you do the same thing for the second set here. Pause the video and try 8, 9, and 10 on your own here, and we'll check them here in a little bit. Alright, these ones, first 2 were combinations. First one, it was just a group of 10 books you were taking. Didn't matter how you packed them in your suitcase, but you couldn't pack the same book twice, so no repeats. Second one, with a lottery, it didn't emphasize this, but repeat, well, for this first part, it says you must correctly select 3 numbers from 30 numbers. A lot of times how these work, especially with the Powerball compare it to that is they have numbered balls kind of in this machine popping around, and then they pull them out of there to select them. Okay, so there really aren't repeats allowed. If I were to give you a quiz or test over that, I would emphasize that repeats weren't allowed, because that isn't something I would expect you to know. I do emphasize that the order is not important here, and that's what makes it a combination. Last one was a permutation because they had different jobs. If you rearrange those, they'd be learning different lines for their roles, so that definitely makes a difference. So permutation on that one. And all these problems, when you do your homework, I'm going to ask you to write out what you thought it was, and then the formula you're typing in your homework. Then be sure to add an appropriate label to the end. Okay, if you get stuck on any of them because they're tricky, be sure to come in to ask questions.